Hey everyone, and welcome. Today we're diving into a really powerful concept in Java, something at the very heart of object-oriented programming. It's called method overriding. It's basically how a child class can inherit a feature from its parent, but then give it its own unique twist. This is absolutely key for writing code that's flexible and easy to manage, so let's get right into it. So inheritance is pretty awesome, right? A child class just gets all the methods from its parent class, like for free, no extra work needed. But that brings up a really important question. What happens if the child class needs that exact same method to do something totally different? That's the problem we're here to solve today with method overriding. Okay, before we go any further, let's get one thing straight because this trips a lot of people up. Method overriding is not the same thing as method overloading. With overloading, you're in the same class and you have methods with the same name but different parameters. With overriding, the method name and the parameters are exactly the same, but the change happens in a child class. It's a super important difference to keep in mind. Honestly, the best way to wrap your head around this is just to see it work. So let's walk through a super simple example with two classes. We'll just call them Class A and Class B. First up, we've got our parent, Class A. Inside it, there's one simple little method called show. And when you call it, all it does is print in a show to the console. That's our starting point, the original behavior. All right, now we make Class B, and we say that it extends Class A. That means it inherits from Class A. Instantly, Class B gets that show method, completely free of charge. It's just there, ready to use. So here's the fun part. If we create a new object from Class B, and we call the show method on it, what do you think happens? Well, Class B doesn't have its own show method yet, right? So Java looks up the family tree to its parent, Class A. It finds the method there, runs it, and boom, we see in a show on the screen. It's using the parent's version. And this is the big question. What if we want the show method to do something different when we call it on a Class B object? We want it to have its own unique personality without messing with Class A at all. This is exactly where method overriding comes to the rescue. It's the official term for when a child class says, hey, thanks for that method, parent, but I've got my own way of doing things. It provides its own specific implementation, basically replacing the inherited one. And how do we do it? It's surprisingly easy. We just go into Class B and define a method with the exact same name and parameters, show. But inside this one, we tell it to print in B show. And just like that, we've overridden the parent's method. So now check out what happens. When we create a Class B object and call show, Java finds the method right there inside Class B. It searches over. It executes this new local version, and the output is in B show. The parent's method? Totally ignored. Now that is the power of overriding. All right, the code makes sense, but sometimes a little real-world analogy really helps make a concept stick. So let's think about this like it's a couple of phones. Just imagine, you don't have a phone of your own. So what do? You use your dad's old Nokia. That's the inherited feature. But then you finally get your own phone. From that moment on, whose phone are you going to use? Yours, of course. You've provided your own implementation, and it's always going to be your first choice. And that's the bottom line here. Just like in real life, a Java object always gives preference to its own methods. It looks in its own class first. Only if it can't find what it's looking for will it go check with its parent. Okay, that analogy should help build some intuition. Now, let's take this idea and apply it to a more practical coding problem. How about a calculator? So here we have a basic calc class. It's got one job, really. It has an add method that takes two numbers, n1 and n2, and just returns their sum. Super simple, very straightforward. Now, let's say we want to make an advanced calculator that extends the basic one. At first, we don't give it any of its own methods. So if we tell it to add 3, 4, it just uses the parent's logic. And sure enough, it gives us 7. But what if our add calc has a weird little quirk? What if, every time it adds, we wanted to add an extra 1 to the result? Well, we can do that by overriding the add method and just changing the logic to return n1 plus n2 plus 1. And so now when we call add 3, 4 on our advanced calc object, it uses its own special overridden method. So 3 plus 4 plus 1 gives us 8. See? We completely changed the behavior in the child, and we didn't have to touch the parent class at all. Now, overriding is incredibly powerful, but with great power comes, well, some rules you have to follow. This is the kind of stuff that shows up on exams all the time, so let's make a quick checklist. There are 3 rules you absolutely cannot break. First, the method name in the child has to be exactly the same as the one in the parent. Second, the parameters, the number of them and what type they are, must also be a perfect match. And third, none of this works unless you have an inheritance relationship. The child class must extend the parent. All right, we've covered a ton of ground here, so let's just take a second and do a quick recap of the most important things to remember. Let's put these two side by side one last time, because it's so important. Overriding is all about changing a parent's behavior. It needs inheritance, and the parameters have to be the same. Overloading, on the other hand, is about having multiple methods with the same name, but they must have different parameters, and it all happens inside a single class. So to wrap it all up, method overriding is what lets a child class put its own spin on the tools it inherits. It's a huge part of what we call polymorphism in Java, this idea that objects can take on many forms. And just remember the golden rule: the child's method always wins. This gives us so much power to write really specific, flexible, and awesome code. And that's pretty much it. I'll leave you with a little challenge to chew on. Think about a general vehicle class with a move method. How would you use what you just learned to make a car object's move method talk about driving, while a bicycle's move method talks about pedaling? Give it some thought. Thanks for watching, and keep on coding.